Hello everyone. Section review for chapter 22, section 3, grade 12. Question number 1. What are the similarities and the differences between fission and fusion? First, similarities. Both are nuclear reaction. Both fission and fusion are nuclear reactions that release energy. The differentiation between them: in fission, a heavy nucleus split into two or more things or atoms, but in fusion, two light nuclei combine. Question 2. Explain how nuclear reactor catalyze chain reactions. The excess neutrons produced by each reaction are used to induce additional reaction. Because the excess neutrons produced by each reaction are used to what? To induce additional reaction. Question 3. What is enrichment? Why is enrichment necessary when uranium is used as a reactor fuel? Enrichment is the process of increasing the amount of uranium-235 in reactor fuels. This is necessary because uranium from ore contains mostly uranium-238. Question 4. A fission reaction leads to the formation of barium-141 and the krypton-92 when uranium-235 absorbs a neutron. How is this reaction expressed symbolically? Question 4. This is answered by neutron 01 paired to uranium-92-235, the mass number. It will produce barium plus krypton plus 3 neutron. Here, how many neutrons are released in this reaction? 3 neutrons. 3 what? Neutrons. Question 5. What are some advantages to fusion reactors as opposed to fission reactors? What are some difficulties in the development of a fusion reactor? Fusion reactor produce less radioactive waste, and the fuel water is plentiful. Difficulties include the high temperatures and densities necessary to achieve controlled fusion reactions. The last question, critical thinking. Why would a fusion reactor produce less radioactive waste material than a fission reactor does? A fusion reactor produces less radioactive waste than a fission reactor because fusion produces a nuclei that are more stable than the nuclei produced by fission. This is section review in your textbook, section 3. After that, booklet questions. Question number 1. Which of the following processes correctly describe a nuclear fission reaction? The two light nuclei bind together to produce a heavier nucleus and energy? No. Two heavy nuclei bind together to produce heavier nuclei and energy? No. A heavy nucleus splits to produce lighter nuclei and energy? Yes. This is the answer. Heavy nucleus splits to produce. Answer C for question 1, the C. Question 2. Which of the following processes correctly describe a nuclear fusion reaction? is the opposite. Fusion, opposite of fission. You know, fusion comes from two light nuclei bind together to produce heavier nucleus and energy. This is the answer for 2. Question 2, the answer A. Yes. Question 3. What value must the mass number of an isotope be greater than for fission to occur? 58 until 60. The answer is 58. Question 3, the answer B. Question 4. What property must a substance have if it is to control a fission chain reactor? The answer, it must absorb a portion of neutrons produced by the reaction. The answer D. Question 5. What type of particle is captured by other nuclei in a nuclear chain reaction, triggering additional fission events? Question 5. The answer is electron or proton or neutrons or neutrinos. The answer C, neutrons. Question 6. What is a nuclear reactor? Nuclear reactor is a system designed to maintain a controlled, self-sustained chain reaction. The answer is D. Question 7. What is the initial series of nuclear fusion reactions that produces energy in the sun called? 7. Yes, the answer is the proton-proton cycle. B. Question 8. Which of the following is not an advantage of nuclear fusion reactors? Question 8. Yes, the answer is C. Repulsive forces between deuterium nuclei are easily overcome. Question 9. Explain why uranium-235 is used in fission reactions, but uranium-238 is not. Question 9. Because uranium-238 has a tendency to absorb neutrons, so that any fission reaction that takes place in a uranium-238 loses energy. This prevents a chain reaction from occurring. Uranium-235 produces enough neutrons and doesn't reabsorb them in the process for chain reaction to occur, and so sustained energy from fission is produced. The last question. Explain why fission reactions are much easier to harness than fusion reactions for the commercial production of energy. For fusion of hydrogen isotope to occur, separate nuclei must be brought close enough together for the strong force to take effect and fuse the nuclei together. This means that the electrostatic repulsion between the nuclei must be overcome by forces even greater than the repulsion. Fusion reactors have as yet not been able to sustain such forces long enough for practical use of the energy obtained from the fusion reactions. Fission reactors don't require anything more than fuel that can produce chain reactions and substances that can control those reactions, so these reactors have proven much more practical to construct and operate. This is finished Section 3